If aging gracefully were a sport, caloric restriction would be the reigning champion. Ripped, efficient, and annoyingly disciplined. But for most of us who enjoy eating more than monk-like asceticism allows, the thought of cutting calories by 30% for the rest of our lives sounds about as appealing as chewing cardboard on a first date. So the million-dollar question becomes, can we slow aging without feeling constantly hungry? Enter omega-3 fatty acids, the nutritional powerhouses that may just offer a friendlier, fork-friendly route to many of the same anti-aging benefits, but with significantly more dinner. Let's start with why caloric restriction, CR, gets so much love in longevity science. CR, defined as reducing energy intake without malnutrition, has been shown across multiple species to extend lifespan, improve metabolic efficiency, reduce oxidative stress, and suppress chronic inflammation. At the molecular level, CR flips on genes and pathways associated with cellular repair and stress resistance. Think AMPK activation, reduced mTOR signaling, increased autophagy, and enhanced mitochondrial function. It's like putting your cells into maintenance mode instead of full throttle wear and tear. But it comes at a cost, namely constant hunger, potential muscle loss, and social awkwardness when your only dinner plan is ice cubes and a multivitamin. Omega-3 fatty acids, particularly EPA and DHA, may offer a fascinating alternative. While they don't mimic caloric restriction in every way, they intersect with many of the same biological pathways and, in some cases, may offer advantages without requiring major lifestyle upheaval. So let's break down how these marine-derived lipids stack up molecule by molecule. First, inflammation. Chronic low-grade inflammation, known affectionately in gerontology circles as inflammaging, is a key accelerant of age-related decline. CR is known to reduce inflammatory cytokines like IL-6 and TNF-A, contributing to its disease-fighting magic. Omega-3s do the same, but in a more targeted way. They serve as precursors to specialized pro-resolving mediators, SPMs, such as resolvins and protectins, which don't just suppress inflammation but actively resolve it, helping tissues return to homeostasis. This is especially important as we age and our immune systems become prone to overreacting like a drama queen in a soap opera. Next, mitochondria, the engines of the cell and frequent victims of time. CR enhances mitochondrial biogenesis and function, helping cells produce energy more efficiently with less oxidative damage. Omega-3s, particularly DHA, have also been shown to improve mitochondrial membrane fluidity and reduce reactive oxygen species, ROS, production. Some studies even suggest that omega-3s increase the expression of genes related to mitochondrial fusion and energy homeostasis, meaning they might keep your cellular batteries charged longer without needing to cut dessert. Then there's the question of autophagy, the self-cleaning process cells use to break down damaged components. CR is famous for upregulating autophagy, which helps maintain cellular quality control and may reduce the accumulation of toxic proteins associated with aging and neurodegeneration. While omega-3s don't have the same autophagy-boosting notoriety, emerging evidence suggests they can indirectly stimulate autophagic processes, especially in brain and liver tissue, by reducing inflammation and improving membrane signaling. Think of it as a quieter kind of janitorial support. And what about gene expression? Caloric restriction upregulates SIRT1, a sirtuin protein linked to longevity, downregulates mTOR, and tweaks FOXO and PGC, 1A pathways that govern stress resistance and metabolic regulation. Omega-3s have been shown to influence many of these same pathways. EPA, for example, can activate PPAR receptors, which in turn modulate lipid metabolism and inflammation, while also interacting with AMPK, one of the key regulators also activated by CR. There's even evidence that omega-3s can modulate DNA methylation patterns, potentially influencing biological age at the epigenetic level. So while it's not a perfect overlay, the Venn diagram between CR and omega-3s is more of a meaningful handshake than a polite nod. But here's where omega-3s may pull ahead in the race for real-world application, compliance, and safety. Caloric restriction, despite its biological brilliance, can be hard to sustain over time and may carry risks, like reduced bone density, lowered immunity, and impaired wound healing, especially in older adults. Omega-3 supplementation, on the other hand, is safe, well-tolerated, and comes with a side of cardiovascular protection, improved cognitive function, and potentially better mood. Not bad for something you can get from a bottle or a really good piece of salmon. So, Is omega-3 supplementation a full substitute for caloric restriction? Not quite. CR still has unique benefits, especially in models where lifespan extension is the endgame. But omega-3s offer a compelling, low-barrier strategy for accessing many of the same protective pathways without the gnawing hunger, social isolation, or hangry existential crises. For aging adults seeking to slow the biological clock without drastically overhauling their lifestyles, omega-3s might just be the spoonful of science that keeps the years from piling on quite so fast. In short, less fasting, more fatty acids, and your cells may thank you with a longer, stronger, and slightly tastier life.